myself and along with my team member Samyukta, and also with my professor Jongwook, we worked on the top research topic that is predictive analysis for Airbnb listing rating using scalable big data platform. So here is my contents of the table, like what all things I'm going to discuss today, like why we need to predict the Airbnb listing rating, and what are my data set details, the hardware specifications, and the machine learning algorithms are used for the Airbnb listing rating, and the flowchart of the project, and lastly, the comparison of results of ML classification model. So here I'm going to discuss like why we need to predict the Airbnb listing rating. Our aim is to build a model that classifies a property as highly rated or low rated based on the features of the listing. And it also helps the Airbnb host to make certain changes to the properties so that they are they are listing in order to increase the customer satisfaction and attract certain potential bookings. It can also serve as a baseline to understand the factors that contribute to the popularity and rating of a listing. So here is my data set details. My data set file name is Airbnb listings. Initially, it was of 4 GB, but we performed some data engineering process, and we filtered the 4 GB file to 400 MB file because we wanted to contain only the Airbnb listing of the United States. So my file format is CSV, and this is my dataset URL. So this is the hardware specifications. The tools we used was Databricks runtime version, that is 8.2 machine learning. And it has 4 nodes. It has 16 CPU cores. And the file system is known as Databricks file system with the Python version that is 3.8.6. So these are the machine learning algorithms which we used for predicting the Airbnb ratings. Basically, these are the classification models that are decision tree classifier, random forest classifier, gradient boosted tree classifier, logistic regression, and lastly, support vector machine. So this is the flowchart of the entire process. Initially, we collect the data here in this step, and in the next stage, we clean the data. That is, we remove the unwanted values like missing values or the null values, something like that. And then we perform the feature engineering process in this stage. And next, we split the data set here in this stage into 2 ratios, that is 70:30 ratio. 70% of the entire data set will be used to train the model, and 30% of the data set is basically used to test the model, that is performing the validation. So in this stage, we pass the prepared data to machine learning model to find the patterns and to make certain predictions. And here in this stage, we use 30% of the data to provide unbiased results of a final model of the trained data set. Next, here the final result, that is the evaluation step. Here we use certain metrics to determine the performance of the entire machine learning models. Like we use metrics like AUC, precision, recall, like that. So if the accuracy of the model in this evaluation stage is like more than 90%, then we assume that the model is good for our rating prediction. If it's less than or equal to 50%, then we assume that it is not a good model, and we continue to follow the entire steps again by replacing the next machine learning model. So here in this step, we are predicting the listing as good rating or not. We focused on the column that is review scores rating column, and we converted it to a categorical feature. And next, we basically classified it as high rating and low rating based on the condition, like if review scores rating has values greater than or equals to 80, then it is considered as high rating. If it has review score ratings less than 80 values, then we consider it as a low ratings. So using the two classification model, we build the model to classify the listings as high and low rated, and also based on the features of the listing. So actually these accuracy, computing time, and AUC precision, these are all the measurements, like the metrics to determine how well our machine learning algorithms or the classification models are performing to predict the ratings. So here in this scenario, we intend to reduce the number of false positive values to gain a higher precision value. And the AUC value, that is the area under curve, are another important factor to determine the accuracy. Here, the computing time metric is the time taken to execute, to train the model, how much time it's taking to train the model for each algorithms. Next, this is my first classification model, that is the decision tree. As you can see in this table, this is the true label and the prediction, right? If the actual value is 0, still it has predicted 1 in few scenarios. And these are the main metrics to determine how well our model is predicting. That is true positive, false positive, true negative, and false negative. So precision and recall. The overall time it took to execute or to train the model is 1.15 minutes. The AUC is 0.972. The precision value is 0.983. The recall is 0.984. Next is the random forest classifier. As you can see in this table, the actual value is 1, and it has predicted correctly as 1. 1 and 0 are the values like high and low rated. And also the metrics are same: true positive, false positive, true negative, false negative, precision and recall. In this scenario, it almost took 2.13 minutes to train the model, and the AUC value is 0.979. Precision value is 0.985, and recall is 0.993. Next is the gradient boosted tree classifier. This model, it took almost 2.35 minutes to train the entire model, and the AUC is 0.977. The precision is 0.984. The recall is 0.993. And I displayed only the 5 values at the moment, and the actual values were like 0, and it predicted accurately like 0 values. The fourth model I used was logistic regression. And as you can see, the top 4 values are actual values 1, and it predicted accurately as 1. The last value is 1, and it accurately predicted it as 1. The AUC is somewhat a bit less as compared to other models, that is 0.959. The precision value is 0.968. The recall is 0.9998. And it took almost like 1.47 minutes to train the entire model. The last model is the support vector machine, and it also somewhat accurately predicted it, as you can see in this table. It took almost like 4.4 minutes more than as compared to the other models, like to train the model. And the AUC value is 0.958, precision is 0.966, and the recall is 0.998. So here is the overall comparison of results of the all 5 classification models. Like, as you can see, all the values are more than 0.95, like 95% of the values are accurate. But if you determine like random forest and the gradient boosting classifier, they are somewhat similar. This one is 0.984 and random forest 0.985. The model with the highest AUC is random forest, that with 0.979. And decision tree has the least computing time, that is the 1.15 minutes as compared to all the models. So to conclude, the metric computing time in the decision tree is the most efficient with least value of 1.15 minutes. The random forest and gradient boosted tree models, they really performed well to classify the high and low ratings in the United States. And the random forest model is the optimal model for predicting the accuracy. And to conclude, thank you for listening. And if anyone has questions.
Thank you for presenting your topics. Yes, if you have any questions about these presentations, feel free to give them comments and questions. Yeah, Professor Lee.
Yeah, two questions. So first of all, thanks for the presentation. I like to know what is the reason to classify over 80 as a good and below 80 as a not good rating? And my second one is there any meaning or implication of measuring the time of validating and creating model? Is it supposed to be computing time? It's supposed to be different by different computing systems. So that's my two questions. Thank you.
What was the first question?
First question is that you use the 80 rating 80 as a good and not good. So of course
yes.
You need the classification model. So you will have to make it binary dependent variable. So I just want to know the reason why you use 80, not 75 or not 85.
Oh, okay, that one. Actually, the actual ratings on the Airbnb website is like listings. They have values from 1, 2, 3, 4, 5. So the data set which we used, it had values till 100. So we wanted to classify it as like somewhat in the range of 1 and 0, so that we can predict how well our model is good in predicting the ratings for Airbnb.
I understand. I just want to know because sometimes we measure median. So
yes,
greater than median becomes good and less than median becomes not good. So, or we use an average. So I am just wondering why you said 80 out of 100 being the good and not good. Because this is very typical question if ever reviewer might ask you if you submit this paper to journal.
Okay, so actually we had values till 100 and we thought of considering it as 80 so that we can classify it as high and low values.
Okay. All right. Yeah, my second question is about computing time. So is it meaningful enough to report a difference in the computing time of those different models? Is that computing time different by different system or different data set? And so I'm wondering why the computing time is important thing to report.
The thing is like how much time it takes to train the model. The data set is loaded in one place and then we are just using the different classification models to execute it. So in this scenario, we can show that this model is very fast in training the model as compared to other models.
Okay. So
that's the reason
so reporting a model is faster than the other with one specific data and one specific system. Would be something that will provide some implication to the methodological knowledge, or is it something that, I'm not sure because I'm not from computer science, so it might be important for the computer scientist, but I'm not sure. So is it common to report the system performance? So it might be my bad. I'm asking even this question, but not sure if it's meaningful enough to ask a question, or maybe the reported computing time. Because I understand the transition recall and AUC is important measure for the performance of the classification model. But I want to know, is it meaningful enough to compare computing time of different classification model with a specific data set and a specific computing system? So is it always like that? And then means that is the implication, is it always good to use decision tree when we actually predict the good and bad of the Airbnb ratings, is it always good to use a decision tree have a faster computing time? So I'm not sure if I have delivered my question properly.
No, actually, there is only, I'll try to elaborate. There is only one data set which we are using, and we are trying to execute all the models for that particular data set. We have only one system. Yeah, in the technical specification, I mentioned that the 4 cores we are using, and that is where our data set is there. So we are just, from this computing time, we are just seeing how quick it is to train the model, because the data set is the same, that is 400 MB. And from this, you can analyze that decision tree model is somewhat, which is quick. And you can see the support vector machine. It is running the same data set, but it took almost like 5 minutes, somewhat like that.
Yeah, so it means that
Professor
it is...
Lee, can I add one more here?
Yeah, please.
Yeah, thanks for asking the question. Actually, you know, we have used the big data system. It means that it has number of nodes. Depends on how big the data set is. So, for example, if we use traditional system, when you build a model with, for example, 40 megabyte of a data set, it takes like 6 hours or 8 hours to train the model. Oh, I'm sorry. When we use like 400 megabyte of data set, it takes like 8 hours or 9 hours to build a model. But if we use like a big data system with multiple nodes, the time to build a model is like 1 minute or 2 minutes or 5 minutes, depends on what kind of model we have used. So we try to explain that when we use like a big data system with multiple nodes, we can also shorten the time to build a model.
Yeah. Okay. All right. So thank you very much. So it doesn't mean that whenever we want to use Airbnb prediction model with a big data system, it doesn't mean that we will always recommend it to use a decision tree if we want to have the fast enough result.
Exactly.
Right? Because it's really specific to the data.
To build a model, because the time to build a model is 1 minute, 2 minutes. I mean, people do not care, right?
Yeah, sure. That was my question. Yeah. All right. Thank you.
Actually, that's a good question and answer. So how about moving to the Professor Kim's questions and Professor Han's question, then let's wrap up this presentation.
Yes, thank you.
Sorry about that.
Yeah, presentations.
Thank you.
Yeah, my question is how you can proceed this paper. Like for me, the hyperparameter tuning is very important to say that this model is very useful in predicting something. And just to try to, my recommendation is just to try to use some auto validation, data set to say that which one is better. And using a big data system is very important to minimize the efforts of like computing times, but predicting is more important than the actually the processing time. So my recommendation is that you just collect the other data to validate that and try to do some additional efforts to do hyperparameter tuning. Thank you.
Very good. Thank you. And Professor Han?
Oh, yes. So I'm just curious, related to rely on the Dr. Lee's question. So still 80% to me, I was wondering, is there any reference or statistical reference? Because to me also is 80% is pretty high. And the second question is there any specific reason why you use only compared AUC instead of the close validation, any other close validation MSE values to compare the models? And the last question is, to me, is the first 3 models that performs very similar. So did you try to mix some classification models? It's like ensemble models.
Let me answer the third question first. Actually, random forest, for example, is basically ensemble model.
Yes.
So simply we can say, yeah, random forest is one of them. And
okay.
The second, what was your second question again?
Second question is, your team is only considered AUC. So did you have any chance to compare the other metrics? It's like cross validation, MSEs.
Oh, actually,
CVs.
we have used the cross validation for generalization, and also we actually focus on 3 accuracy measurement. That is precision and recall and AUC. However, the precision is more important because we need to reduce the
false positives.
Exactly. So that's why we give more weight to the models that have a much higher precision. So actually, we can say precision and AUC are more important for determine which model are better for the rating prediction. And first question, yeah, that one, the 80. I mean, why we choose 80% for higher rating? We haven't used any statistics. We just use from rate 1 to 5. Rate 4 and 5 should be the highest rating that
highest.
Yeah, people normally use as an intuition. So yeah, maybe we need to think about any kind of reference to support our decision instead of just using our intuition, I guess.
Yeah, I just wondering because if you use the higher or lower rate, maybe your models are different or it's still consistent. So I'm just curious.
Yeah. I know. We just thought that people just love the rating 4 and 5. That's why we have chosen the 80%, especially for rating 5, that people really love.
All right. Thank you so much.
And I would like to add one point, to predict the accuracy, how well our model is predicting. For that, the main metrics are precision, recall, and AUC. So our goal was how accurately it is predicting. For that, we emphasized on precision and AUC values.
Right. Thank you for questions, all the questions, and thank you for all answers. Actually, it's a desirable conference, right? Kind of active discussions about a topic. Actually, I'm not a machine learning scholar, so I'm not arguing. I don't have any questions about the method and anything. But at the very beginning of the presentations, I was just wondering why the Airbnb is a research context. So when you prepare any papers and when you prepare for presentations, and reviewers or any audiences may ask about why you selected Airbnb instead of Yelp or TripAdvisors, and then they may ask the importance of your context. If I missed that, then you may think about it. Okay? Right. So, go ahead.
Actually, I checked online, many articles I have been going through. So basically, most of the students, they try to predict Airbnb prices and all those things. So there are rarely few concepts or articles, available online for the Airbnb ratings. So we were curious to predict something like this.
All right. Okay. Thank you. Yes. So there could be a good justification as well. So that was my question. The next presentation is mine. So I shared my